Welcome everyone for this SPHN seminar. I'm very proud to have two speakers today from the WHO, so from the World Health Organization, which are Robert Jakob, who is the unit lead of Classifications, Terminologies and Standards unit at the WHO, and Nenad Kostanjsek, which is the technical officer at the WHO. And as you all know, in SPHN, one of the major goals is actually how can we standardize data and semantically describe data to make them usable for research. So when we are sharing data across institutions or even internationally, how can other people understand what was the meaning of that data? And of course, for achieving that, we are using a lot of international standards to really be aligned also with the international community. And I think today's webinar is really at the core of this main goal of SPHN, because it will provide us an introduction to a new standard or a new version of a standard, which will be ICD-11. And I'm very excited to see how ICD-11 hopefully will actually move us towards this goal of really describing complex data which we use for the research aspects in a standardized way. And I think with that, I would like to give the floor to our speakers. Robert, the floor is yours.
So thank you very much. Buongiorno, colleghi. Guten Tag, liebe Kollegen. Bonjour, chers collègues. But we'll do the presentation in English so that we have the kind of common denominator that doesn't be preferential to everybody. I'm talking here about the International Classification of Diseases, 11th revision, but also a little bit about the context of this classification. Just as a basics, really, the ICD is a legally mandated global health data standard and has come into effect January this year. So that means that the countries have committed to use ICD-11 for recording and reporting mortality and morbidity nationally and internationally with the ICD-11. In practice, there are always delays in the implementation because many systems need to be updated. The ICD-11 is designed in a way that it's independent of language and culture. It has been around for a long time. In the past, the only point was comparable statistics. Now, with the digital world, of course, we also talk about semantic interoperability. The ICD serves to code many more things than just diseases. It's illness, causes of illness and death, injuries, causes of injury, and many more. And the ICD-11 here is the most recent revision. It has been adopted at the World Health Assembly by all countries in 2019, exactly for coming into effect. And one of the big differences compared to the past is that we are not talking about a product that is composed of 3 books, one being a tabular list, one being an index, and one being some instructions, but essentially that we've integrated all the things that were hidden in the index in the core classification scheme so that we built something like a modern ontology that still is growing with internal relationships, instructions for users, and anything else. This means really that the ICD-11 is also fully digital. We are making some paper usable output, but the question is who's going to really use this? And one other aspect is that, of course, the ICD-11 has been scientifically updated and is more closely linked to the scientific societies than is ICD-10. And just remember that ICD-10 has been produced in 1990. So it's quite an outdated conceptualization in many areas of health. And the other thing is that with ICD-11 now you really can code to an extremely high level of detail individual cases as much as you like. But let's see a little bit the context here. So the ICD is not alone. I will show more. And the basic idea is, I think, the same that Sabine shared in the introduction, to really have a common information base that allows shared data across systems, some of which have a direct impact on patient health and health management. Others have an indirect impact of patient health. And then, of course, there is this kind of vision that people like to talk about, big data and machine learning, artificial intelligence and other nice things, but where we on the other hand say this, especially big data and machine learning requires, of course, very clean data, and their question that needs to be solved, how clean is the routine data? Will it enable this kind of uses? Now, the ICD-11 has really been designed having the de facto uses in mind, and the oldest and longitudinally most existing use case is certainly cause of death coding, but a de facto use case is also case mix and resource allocation, cancer registration, patient safety, clinical documentation, functioning assessment, primary care, prevention, and the goal was to allow with ICD-11 to get to a level of detail that is even helpful for advanced research in different areas. Now, looking at this family of classifications, if you want to cover the things that are tendentially interesting in health, at least for public health management, you have diseases and things that relate causes of illness. Then you have ICHI interventions that allow to code all kinds of interventions, meet clinical, diagnostic, therapeutic, prevention, public health, nursing, so other things. And then, of course, the functioning, so the fitness of the individual that's coded here as ICF. And we want to complement this information, of course, with things that WHO is also producing, for example, the non-proprietary names for pharmacoactive substances, WHO device list, the histopathology of tumors, and all the others that are listed there. But we know that sometimes people want to aggregate data for different purposes, like, for example, for nursing, for family medicine, for medicament dosage use, and other aspects. We also know that there are specialized terminologies around that some people use, some others don't. So we are working to have linkages with these systems with the aim of having one-to-one representation rather than some kind of fuzzy links between the system. Now, we built this kind of smiling face because all these systems are essentially accessed through a very, very simple user interface. That was one of the goals. So for the routine cases, one would go to this kind of coding tool that really looks like a Google interface, and then you search the things that you need with the language you need. The whole support for the maintenance of the classification is closely linked to government and collaborating centers and non-governmental organizations in the scientific level, and of course also to the different levels of WHO. And this map here shows the countries that have some involvement with the maintenance. The darker, the more intensive, but essentially it also shows that we have global input when it comes to completeness and correctness of the classification itself. And here, just to give another view on this global collaboration, so we have these links with the terminology systems, for example. We have more than 300 institutions contributing on research input, and just listing here a few. We have medical science and implementation. Some links, several societies are linked to this activity, and also inside WHO, we are cross-cutting work with different things like guidelines, health services trials, antimicrobial resistance programs, or on the scientific and coding side, we are linked to these different activities. Now, the ICD-11 is published within a certain paced process to seek to bridge the discrepancy between the need for stability in a statistical component, statistical surface of the classification, allowing to do some longitudinal statistics. This means the statistical impact changes usually are done now every 5 years. Whereas at an annual level, we can do updates in terminology, adding synonyms, adding things below the surface. Now, all this input, of course, is then processed. We have scientific review groups say more than 300 different groups are involved, people are involved directly. We have a proposal platform where everybody can provide some input. And at the moment, we have some 20,000 users on the platform. We have some proposals for updates. So since the start of the revision, we have processed some 17,000 proposals, some of which may relate to correcting a comma. Otherwise, others may relate to restructuring, for example, some respiratory disease. And then we have, of course, our core ontology editor that is based on the protege of Stanford, and that allows then to do this kind of multiple relationships, to add descriptors, code combinations, where we now at the moment have something like 130,000 terms on the system. We have 85,000 entities, so concepts in the system, but with the instructions linking the different entities, the API can address easily some more than 1.6 million expressions automatically. But this is automatically means where we know that users need some typical combinations for full expressivity. We have put them in the system so to make the life easy, but in principle, you can do any kind of combination that makes sense to describe the case you want to describe. All this is underpinned by a backbone where we have this authoring tool I mentioned. Then we have the content repository with multiple languages. And the whole thing then goes to the API. You'll see more to this later, that then allows to really address what is output in the browser, coding tool, field implementation, and some other things. And of course, this is also linked to the maintenance platform that has the proposals that then feed back into the authoring tool as soon as they have been reviewed and agreed upon. So ICD-11 implementation status is shown here. So anything, the lightest blue means there has been information disseminated. The next blue means the language is available or in the process of being made available. And then the darker ones means that implementation activities have started that we know of, meaning that could be that there has been a decree or a law saying now we start, and some pilots in the field or even national rollout at different levels. The different uses of ICD-11 in 22 we'll see more, but they really cover primary care, secondary, tertiary care, death certificates. We already have a lot of publications. We have information systems using this, and then some WHO guidelines and other things already linked to the ICD-11. But now let's look a little bit at the classification itself. So here we see a prototypical example of the browser where you can see, so we have here a kind of hierarchical view that then, for example, for the pneumonia allows to see what kind of post-coordination code combinations we know of that people eventually may be interested of. And as a special feature here, so all languages that are available will become available in this browser, so that you can choose which one is the language that you're going to make your search in, and which language would be the additional output that you're interested in. And you see here at the moment we have these 5 languages that are available, and here I'm just showing a combination, for example, in with English and Spanish. Now, looking at the coding, so I know that in a clinical context, cancer of stomach is not really what you're looking for. You may be more precise, but just giving this as an example, how the system knows that cancer actually in this formal language of ICD is a malignant neoplasm of stomach. And then the system will show you the best match on the top if you have chosen the sequence of relevance. Now, this is the ICD-10 structure, the ancient structure, where we have a kind of very simple basic hierarchy, a separate text index, a separate rule base, terminology input, so the index, and it's 30 years outdated. So essentially it was a broad system for public health statistics, missing a lot of the important clinical detail, and it was designed as a print product. And now we have the ICD-11, where we have preserved some core component that is still in blue here that allows to do still the statistical aggregation, but you see that this kind of hierarchy is getting much deeper and that there are cross references between the different entities so that it becomes more and more in direction of an ontology, so that we really can say we can code most or all desired clinical detail, eventually using code combinations, and that it really has become a clinical tool for statistical use. And you see here the values that I was mentioning at the beginning. Now, the difference between linearization browser and foundation per se is that the linearization browser really just shows a statistical core and contextualizes, for example, the multiple parenting as something like code elsewhere, and if you want, you can switch on in gray to see siblings that are coded elsewhere, whereas the foundation browser is agnostic of primary or secondary parenting and linearization. It shows the full foundation. Every entity is shown everywhere, is multiple parented. Now, a little bit about the content. So we have new chapters and sections of the classification. So we have diseases of the immune system that have become a new chapter, where different immune diseases that were scattered all over ICD have been regrouped. We have sleep-wake disorders as a new chapter, where entities of the respiratory and of the nervous system have been grouped together. Conditions related to sexual health, where there is no implication about the origins of the condition, and we have an optional section that allows to code traditional medicine diagnosis, traditional medicine conditions, in addition to the standard coding, so that some comparison between the different medicines may become possible for the future. And we have included also the WHO disability assessment scheme that allows to assess the activity and participation in daily life and work environment as an outcome of the disease process, as an outcome of the healing process, to assess this fitness of an individual. And we have seen that, of course, the content is in line with the needs of different initiatives like patient safety reporting, antimicrobial resistance documentation. There's this global network for the GLASS. Then we have the details for diagnosis related to groupings, and of course the broad categories with simple information for use in primary care family medicine. In the neoplasms chapter, we have a hierarchy, a new hierarchy, where the primacy of the behavior of the tumors have been broken to have the tumors of the brain and of the central nervous system and of the blood separated out. Central nervous system because the baby's behavior may be non-invasive, so by definition rather benign, but due to the space limitations by the skull, even a non-invasive growth creates problems and needs to be documented. And similarly for the hematological neoplasms, where depending on the state of research, sometimes behavior changes, disrupting the documentation of the individual entities and also creating trouble with the code area allocation to the behavior of a tumor. And of course, there is new detail, like, for example, tumors added basalioma was missing, melanoma subtypes were missing in ICD-10, now they are there. And in ICD-11, we have the possibility to code grade and stage. They have been added as a post-coordination feature in many places. If more places are necessary, this can be done. You can code the detailed morphology of the tumor, and we are really looking into how to best code also genomic aspects with this, certainly a research topic of great interest. Then nervous system, for example, more clinical detail, and the cerebrovascular diseases have been moved here. Cardiovascular system, new is that we have now distinction of ST elevation and non-ST elevation, myocardial infarction, STEMI and non-STEMI. And the section on arrhythmias and pulmonary hypertension have been updated, and much more. Of course, we have all kinds of coding for COVID-19 and related and derived issues. So the chapter 2 neoplasms also has preserved the structural integrity with ICD-10, so that at the basic level you can even compare with ICD-10, and this also means that the chapter 2 neoplasms corresponds to the ICD-0 topography codes. However, I put here an example where ICD-11 is ahead of ICD-0 because, as many of you may know, the biliary tract cancers are not easily codable with ICD-0 because the anatomy is missing there. So we have it here. And here you see also the example. We say we have added some histopathology already in the core structure, but of course you can go into more detail. And what we show here is a proposed set for post-coordination that essentially also makes it possible to reach things easily to the coding tool. However, the post-coordination, so code combination, are not restricted to the sets that are shown here. Essentially, you can post-coordinate whatever is necessary in your context. New chapter of the immune system. As we said, we have immune deficiency, non-organ specific systemic disorders that in the past were with the musculoskeletal system, autoinflammatory and other conditions. Here we have fully redesigned diseases of the skin chapter, where fusion of the American, British and German terminologies has provided the input, and they had created their terminologies out of despair because ICD-10 was hopelessly outdated and hadn't been much updated since 1948, as they were saying. Now, external causes and functioning, we have more consistent detail in the external causes of illness, of disease, better organization of tract existence, more consistent levels of detail between the different intents of injury, so whether it was accidental, intentional self-harm or an assault. Other sections also have been standardized, and we have a completely overhauled section for healthcare related harm, allowing full documentation of patient safety events, no matter whether they caused a harm to the patient or they did not cause a harm. And then the functioning section that allows to calculate a summary score of fitness of a patient. Now, rare diseases can be coded also with the ICD-11, of course. Some of them, because of historic and other reasons, are at the surface. They have a statistical code. And you see the ones that are here with a blue filled circle in the so-called spider view of the browser. They are codable directly, but then there are others like here in the lower part, the X-linked immunologic disorder that has a white circle. So this is below the surface. All these rare diseases, of course, come with a whole range of synonyms. If you want to code reliably rare diseases with the ICD-11, then you would use the URI, Unique Resource Identifier. And we are updating the content at regular rates with the colleagues of Orphanet so that we have a correspondence with the system. And at some point, we'll even eventually expose the Orpha numbers. So this is a work in progress so that data can be collected accordingly. Now, as I said at the beginning, ICD is much more than diagnosis. Again, you have all this content that is traditional classification content, but then we have what we call the extension codes that allows to add severity scales, temporality, so the course of the disease, for example, anatomy, laterality, consciousness scale for coma, a whole range of infectious agents, list expanding. And well, I'm not going to reread all the things there. Just be aware that ICD already had objects, places, and activities for injury research, for example, that could be there. So you can even describe parts of a building or building types, like the parts of a building, meaning a stairway, kitchen, and so the wealth of information there is huge. Now, here I'm coming to an end now. As I say, these three classifications are getting the same features. ICD is ahead of the two others, but with this, we try to cover the realm of health information so that we can make good use of the data, that you can make good use of the data. And with this, I come to an end. Say thank you for your attention. You see, we have email addresses, Facebook and Twitter, and our websites. Feel free to get in touch if you have any questions. With this, I come to an end. Thank you very much. And I would hand over to my colleague, Nenad.
So I hope you can see my slides. In this, first of all, good morning to everybody. In this second presentation, we would like to give you an overview on the tooling infrastructure of the ICD-11. So this is also a novelty. In the past, when ICD-10 was disseminated, it was basically distributing the book. With ICD-11, we are having a whole range of different tools for specific purposes, which are coming with the ICD-11. And at the high level, we are distinguishing between implementation-related tools, software integration-related tools, training and capacity-building tools, and maintenance. And I will run through some of them in more detail, which might be also of interest to you, particularly from a research perspective, where you are interested in really getting into the granular, very detailed depth of the classification and the diagnostic categories. And in that regard, in particular, what is important to highlight here, the new version of the coding tool, which we have just released for the foundation coding, and talk a little bit about the different options you have for the software integration. Otherwise, you see that we have here tools which are very much designed according to the different use cases. And also in response to some of the comments which I saw, we have mapping tables available from ICD-10 to ICD-11. Now, most importantly, and from a practical point of view, is the use of the coding tool, which is in ICD-10, it was the index, but here you have now an electronic index, and it is access, provides search functionality for the depth and breadth of the ICD-11. You see here, when you type in a particular diagnostic statement, like end-stage renal failure, you get pointed to the correct ICD-11 code. And you notice here there is a blue highlighted search results, which is indicating that this is a full match. So end-stage kidney failure is equated, or actually the search term here was renal failure, but you see in the background, we are doing a kind of synonym equation from renal to kidney, and it's recognized as chronic kidney disease stage 5 and coded accordingly. Now, at the center of the coding tool is here the search results, which are updated as you type in the diagnostic statement, and you get here then the relevant search results which are popping up. If you want to narrow it down, you can go on the left and use some of these additional index terms, which you can order by relevance or also in alphabetic order. And if you activate the filter on the right-hand side, as you see here, you also see how for this particular search term, the results which are rendered, the distribution is according to the ICD-11 chapters. Now, in the background, we have what we call the smart search feature of ICD-11. And you see here some of the highlights in terms of what this search or smart search entails. So, for example, it recognizes similar words and spelling variants. It does understand the synonyms, as we have just seen. Renal or cancer is equated to malignant neoplasm. It has other features like handling compound words. And then there are a number of features which you are well aware of by using any other browser like Google or Bing, where you have support of word completion during the search. You have word suggestions, and the search results are dynamically updated. Of course, it is using in the background an algorithm and a score which is driving it. And we also have in the index incorporated, whenever we come across what we call local term variations, And the early example of end-stage renal failure is one of those. You will find it very commonly used, for example, in death records in some of the, for example, Australian databases. So we incorporated this as one of the term variations. Another example here from the Spanish version in some Spanish-speaking countries. Again, in the death records, they avoid to use the term suicide because of stigma. So they have a synonym which they refer to auto-elimination, and that has been incorporated as a synonym. So when you register and access the browser, you will see under the info tab that there's additional information. You can print out the chapters. You have access to spreadsheets files, which giving you the classification, hierarchy in Excel format, as well as mappings and other features. And of course, the reference guide, which provides you with further background information. Now, for the coding tool, we are basically distinguishing between two versions. The blue, which is the official implementation release version, which is released once a year. So we just had in February this year the official release for 2022. And then we have the maintenance version where work is ongoing on a day-to-day basis. It's updated daily. And you see here the URLs for accessing those respective versions. We have now, as I indicated before, one new version of the coding tool, which allows you to see what is happening at the back end now in terms of displaying what we call the unique identifiers, which are attached to every single ICD-11 entity. So it really allows you, on one hand, to have the statistical view, where you see here the codes, which are assigned to every of these different codes, stem codes or extension codes. But you also see here, up here at the back end, the unique identifier. And that might be of interest, particularly if you do specific mapping work or research work where you really want to have this identified. And I will show this practically in a moment now so that you see how this looks like in practice. So let me just switch to some examples, and I pull here my slides. So let's have a couple of examples here so that you see how this works in practice. So if I have a diagnostic statement, like for example, breast cancer, you see that the coding tool is pointing me here to the malignant neoplasm of breast unspecified. And so it's a blue match. If I now choose to post coordinate because I want to add further detail, it gives me here the options to, for example, specify the laterality, specific anatomy, or the histopathology. But in my case, I just want to add here that it is the laterality that's in the left breast. And you see here, this is the code combination. But you also see the foundation URI, which is displayed here underneath as the unique ID. Now, this is what we call doing a kind of manual post coordination. But you will see if I do this from the very beginning and I type or indicate the laterality, the coding tool points me directly to this code combination, which consists of the stem code, and then we use the ampersand sign and then the extension code. And that happens not only for the laterality, but for other dimensions where we think they are important or very frequent. So for example, if I continue typing here, stage 1, grade 2, you see that it brings me to more extended code combination, which is indicating not only laterality, but also the stage and the grade of the cancer. So this is an example where you see here the kind of quite extensive code combination which is in the code and the respective URIs. What is important to highlight, when I go on the specific detail which is indicated here at the back end, what is stored in the system are these URIs in addition to the code and of course the correct code title. And this is now an example where you see a code combination between a stem code like the breast cancer unspecified and the specific postcode in our extension code dimensions. Now I will show you another example where we have a code combination which is combining what we call two stem codes. Like for example, I have here the type 2 diabetes mellitus, and now I can post coordinate also here for the, let's say, diabetic foot. And it brings me here again to a code combination, and this time I have a code combination between two stem codes. So the causing condition or the manifestation, if it's a diabetic foot, with a cause or vice versa. But I can do the same here in an easier way by just typing in directly. And it brings me to the code combination in an automated fashion with this automated indexing function. So this is happening also here, the example of two stem codes. And the other point I would like to show you is when we go to very detailed diagnostic state conditions, like I think Robert mentioned already, the Hutchinson-Gilford syndrome, a rare disease. You see that this particular disease is, or rare disease is very, very deep in the ICD-11. And from a statistical point of view, it is not really important to really capture this with a code at that level. However, from a clinical point of view, it will be important, and a research point of view, to have it documented. And you can do this now by clicking on it. You have the URI here and the statistical category in which it is reported, under which it is reported are the syndromes with premature aging appearance as a major feature. And if you want to have this just to see how this looks like in the foundation that you see here, you see there are many, many other very specific, like the Werner syndrome and other syndromes of premature aging, which you find in the ICD-11. They are so-called under the shoreline entities. And you see here, they're all rolled up or listed under this codable entity, which are the syndromes of premature aging. And the same would be applicable to other examples when you go into the cataracts, for example, the posterior polar cataract. And you see also that it is a very, very specific type of cataract, which are listed under congenital cataracts, actually in the area of development anomalies. So you can code, as Robert indicated earlier, this very detailed, very clinical detail. You find it there, and it is aggregated to the higher level statistical categories. So, and the last example I wanted to show you is if you, of course, go into searching the extension codes, you will also find there the specific entities, for example, for COVID vaccine, which you see here now searchable. In order to find these extension codes and search for them, you would need to activate the filter. by default, we are switching off the extension codes to reduce the complexity, but you can activate and customize your search so that it becomes accessible. So let me quickly move back to the presentation to highlight one or two more other important aspects. Now, all of this, what I have shown you, is accessible also for consumption in any kind of software environment. So you will find on the ICD-11 API page all the information on how to use the APIs. We have also another layer on top of the APIs, which is the embedded classification tool, which provides you access to the same kind of user interface of the coding tool you have just seen. And that can be also deployed locally, so offline, using Docker container, Windows services, or Linux system services. And it is, of course, as an international public good, like the rest of ICD-11, free of charge. So you just have to register and you can then consume the APIs. What I would highlight here in particular is the fact that under these APIs, you have this language-specific layer where you see some of the features I also highlighted earlier in the smart search functionality are embedded and included. So this provides you really with the full search functionality with this language-specific layer in whatever language you are using. And then you have, of course, here the access to the foundation, which is language independent. And you see here some of the features I already highlighted. Now, very quickly, here are some examples of how this is now implemented in a number of countries. This is the electronic medical record system from Kuwait. They have a free text data field. This is for morbidity in the hospital, where they indicate the diagnostic statement. Then they activate the search. It pulls up the search. And here for the ST elevation is then coded, and the code is stored together with the code title and the URI. Other examples include the data dictionaries here, for example, in the context of the digital documentation for COVID-19 certificates, where some of the code sets of the ICD-11 are consumed in this data dictionary. In this case, the COVID vaccine code sets I mentioned earlier from the extension code chapter. And that is also the case for other applications in the context, for example, of operationalizing or making narrative guidelines machine readable, computer executable, where data dictionaries are used and ICD-11 is integrated. Training tools are also available for coding purposes, and you see here one of the examples of what is used currently in the countries. There are also other learning courses currently available, and together with the newly established WHO Academy, we are also in the process of developing them. For maintenance and update, we have a proposal platform. This will be particular of interest to you in case you use it and you come across areas which where you suggest improvements, enhancements. So you can go on the proposal platform, you can browse the proposal, you can make proposals, and we very much encourage you following the usage of it to make this kind of enhancements so that it becomes better. We are also doing this very much from a perspective of increasing the capacity of natural language processing in the ICD-11 and in other classifications, the ICF as well as the ICHIs for interventions. And you see here examples where we are basically batch processing large diagnostic term bases and see how we can enhance the index and natural language capacity of the classification. And with that, I come to an end and thank you for your attention.